Hi, we are going to go over the Unit 4, Day 6 Mortgage Word Problems worksheet. And in the Do Now, we have Kellyanne has $20,000 to invest. She puts half of the money into an account that grows at an annual rate of 0.9% compounded monthly. Now, as soon as you see compounded monthly, you should be thinking A equals P times 1 plus R over N to the NT. That's the compounded monthly formula. They want you to write a function, f of t, that represents the money in the account after t years. So most importantly, they say f of t, so we should be writing f of t. We should not be writing a equals. Now, I know that Kellyanne has $20,000, but she's putting half of the money in there. So half of the money is $10,000. So we're really starting with $10,000, not 20. Anyway, we have an annual rate of 0.9%, which means that R is 0.009. And then we are compounding monthly. There are 12 months in a year. There we go. And there is our formula. Now for the next one, Kellyanne still has $20,000 to invest, and she puts half of the money into an account that grows continuously. As soon as you see the word continuous, no matter what, even if it says compounding continuously, you need to write PERT. They want to write a function f of t that represents the amount of money in the account after t years. So we have f of t equals, how much are we starting with? Again, half of the money. So that would be 10,000 still. Your base, because it's compounded continuously, is going to be E. R, you have to convert it to a decimal. And we are done with compounding the continuous formula. All right, now looking at the actual regions question. We had Kellyanne has $20,000 to invest. She puts half of the money into an account that grows at an annual rate, compounded monthly. At the same time, she puts the other half of the money into an account that grows continuously at an annual rate of 0.8%. They want to know which function represents the value of her investment after t years. So you have two scenarios going on. One was the half of the money that grows at an annual rate of 0.9% compounded monthly. So the compounding monthly formula from that do now was 10,000, 1 plus 0.09009 over 12 for monthly to the t. And then the second half of the formula was the other half of the money into the account that grew continuously. Sorry, my pen just stopped working for a bit. All right, so this is her total amount of money, and that's going to be because you add it up. That's usually what total means. Sum it up. You have the compounded monthly part, you have the continuous interest part, and now we are going to see which one of our answer choices is correct. So right off the bat, we could compare the e's. We have 0.008. These have 0.008, whereas the other exponents are incorrect. And now we have to see, is the answer 2 or 4? So we have to look at the blue compounded monthly formula. If you look at this, we notice that the 10,000s are the same, and the difference is the 1.009 and the 1.00075. We don't have either of those. We have this. But notice here how you have a 1t, a 1t, we have a 12t. So we have to find what the true base, the actual growth factor, is. So in your calculator, you're going to have 1 plus 0.009 over 12 to the 12 in the calculator. The 10,000 is going to stay, the t is going to stay, and we are going to put everything else in the calculator. So we have parentheses 1 plus alpha y equals 0.009 over 12, and on the outside, put an exponent of 12, and you get 1.009, blah, 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 blah. What else came after it? 037? And more. There's more stuff. But my point is if you compare it, clearly we have the 1.009 that it is closer to. So your answer would be choice 2. Now I know that maybe you're thinking, well, 0.009 is close enough to 0.9%. That's actually not the reason. There is no connection. That just happened to be like a lucky circumstance that the numbers were so close together. You would truly have to put it in the calculator to see what's the actual base, and it's not necessarily just 1 plus the rate in the first place. Anyway, now we are going on to other interest problems, and before we freak out, you do not need to memorize these equations. The Regents likes to give you really crazy equations just to see if you could put it in the calculator. But you do not have to remember them. You only have to remember 1 plus or minus r, the compound interest formula, and the continuous interest formula. So now we have the Wells family is looking to purchase a home in a suburb of Rochester with a 30-year mortgage that has an annual interest rate of 3.6%. The house the family wants to purchase is $152,500, and they will make a $15,250 down payment and borrow the remainder. Use the formula below to determine the monthly payment to the nearest dollar. So in order to understand these problems, you have to understand what it means to buy a house. When you buy a house, not many people have, like, let's pick easy numbers. Let's say a house is listed for $500,000. That's actually not that bad for Long Island. It's relatively cheap nowadays. So you have a house that is $500,000, but not many people actually have $500,000, so they need to take out a loan. Instead, when you have instead of calling it a loan for buying houses, we call it a mortgage. A mortgage is a loan. We have that for a house. So the thing is, the bank is not going to give you $500,000 for the house if it costs $500,000. They're going to say you have to pay something. So $500,000 is the sale price, but maybe you don't have $500,000, but you have $100,000. That's how much you have. That is called your down payment. So you're showing the bank that you do have some money and you just need a loan to pay for the rest. That means that if the sales price was $500,000 and your down payment was $100,000, then you have to get a loan for $400,000. That is called your amount borrowed. That has nothing to do with this problem. I just picked random numbers to explain a scenario. So let's go back to this problem. We have that we want the formula below to determine the monthly payment. The monthly payment is M. So this is what we are trying to find out. That is a question mark if you can't read it. Now, your amount borrowed, you have to figure out. So how much are we borrowing? Well, we have the total cost of the house, and we have how much we actually have to pay now, your down payment. So if we have a 152,000, that's how much they're asking to purchase the house for, and you have $15,250 to pay for it. How much did you actually borrow? I don't know, I need a calculator for that. 152,000 minus 15,250. So we borrowed $136,750. Now you need the annual interest rate, which can be found here. Just make sure you write it as a decimal. Okay, we have M. Well, we want to find M. We have P, we have R. You need the total number of monthly payments. So when you have bills, unfortunately, we get bills every single month. So if you have a credit card and if you purchase something with a credit card, the credit card company will give you a bill every month. They're going to give you 12 bills a year. So same thing goes for houses. I unfortunately have a mortgage and I have to pay it every single month. I have to pay my mortgage 12 times a year. So if you make 12 payments a year and you have a 30-year mortgage, how many payments are you making in total? We have my 12 payments a year times 30 years. This is going to be, what is that, 360 payments? All you have to do is insert this into the calculator. So we have M equals, P is 136750, R is 0.036 over 12, N is 360, there we go. And you actually should write this, not should, you have to write that to get your partial credit, because the whole thing relies on you being able to plug this into the calculator properly. If you plug this into the calculator, just one single thing is wrong, you're not going to get partial credit if you don't show what you plugged in. So please show this work, and don't do this little by little, do it all at once, all in the calculator. So we have a giant fraction, and up top we have 136,750 times a fraction. And we have 0.036 over 12. Now what? K times 1 plus yet another fraction. Okay, there we go. To the 360th power. And now you're going to go to the denominator. My denominator is also complicated. This is very annoying. But please work slowly, that way you can make sure that everything is correct. Like that, I just missed the 0. There we go. Okay. Double check it. I really hope I'm right. And we'll get $621.73. Remember, rounding to the nearest cent is 2 decimal places. So except it didn't ask you to round to the nearest cent, it asked you to round to the nearest dollar. So that would be $622. So this person is paying $622 per month. It's actually a pretty cheap mortgage. Mine is a lot more than that. Anyway, I hope this made sense. This question was worth 2 points on the regions. You got 1 point for finding the variables that you had to plug in, and the other point was plugging it in properly. Let's try another one. We have using the formula below, and notice how it's a different formula because that's what the regions likes to do. They like to give you crazy ones to see if you could use your calculator properly. Determine the monthly payments on a 5-year car loan with a monthly percentage rate of 0.625 for a 0.625% for a car with an original cost of $21,000 and a $1,000 down payment to the nearest cent. So, how much money did you borrow? How much money you borrowed is equal to total minus down payment. My total is $21,000 for the car, but I already paid off $1,000 of it. That means you borrowed $20,000. You want to figure out, no, you don't. It's your number of monthly payments. You have 12 payments a year. How many years do you have happening? 5 years. That means in total you are making 60 payments. You want to figure out your monthly payment. This is unknown, so we're just going to put a question mark here for now. And then we have I is your interest rate per month. In this case, this is a percentage, so the rate would be 0.00625. So let's see. Oh, these are actually 2 questions in one. Ooh. This is like part A up top and part B on the bottom. Anyway, we have P is the amount borrowed. So I borrowed $20,000. PMT is the monthly payment. We don't know the monthly payment. And then we have this whole mess, which is 1 minus 1 plus I, which is 0.00625, to the negative n, which is 60, over 0.00625. All right. Now, your goal is to get PMT by itself. So you have to divide both sides by this whole mess, by the 1 minus 1 plus 0.00625 to the negative 60 over 0.00625. Jeez, this is long. All right. On the right-hand side, your 2 fractions are going to cancel out, and you're going to be left with PMT. On the left-hand side, this is a big fraction that has another little fraction in the denominator. So your overall fraction, and this is important because if you don't put this in exactly the way I do, you will get a different answer. You're doing 20,000 divided by a fraction. So when you do alpha y equals, 20,000 goes up top. In the denominator, you are dividing by a fraction. So you put the second fraction in the denominator specifically. Any other way won't get this done properly. You have 1 minus 1 plus 0.00625 to the negative 60 over 0.00625, and I'm going to double check my work. I think I'm right. You get 475, let's see, what am I rounding to? To the nearest cent. So I have 476 cents. There we go, that's part A. And then part B, it says the affordable monthly payment is $300 for the same time period. So now they're giving you the monthly payment. This is PMT. They want you to determine an appropriate down payment to the nearest dollar. So you need to work backwards. Let's see. We know that PMT is 300, so I have 300 1 minus 1 plus 0.00625 to the negative 60 over 0.00625. And this is equal to the amount borrowed. Now, your amount borrowed is what we're trying to find, right? No. We want an appropriate down payment. Your amount borrowed is total cost minus down payment. I'm going to call the down payment X because I have no idea what it is. That's what we're trying to find. Our total cost of this car was $21,000. So the amount borrowed is 21,000 minus X. And the amount borrowed is what we're equal to. So we have 21,000 minus X. All right. What I'm going to do is I'm going to bring the 21,000 over to solve for X. And then I'm going to get negative X equals something. I'm not rewriting this all out because I am lazy. I have 300 parentheses. Now I have a fraction. Except apparently I messed that up. So 300 times alpha y equals, there we go, 1 minus 1 plus 0.00625 to the negative 60. My denominator is 0.00625. Double check that you're plugging it in right. That would be helpful. And then we said that we are subtracting $21,000. And you get negative 6028. They did say round to the nearest dollar, so yeah, that would round down. Negative 6028. But that was negative X. If you want positive X, then positive X is equal to positive $6,028. So if you only wanted to pay $3,000 each month, that means you had to put down $6,028 to begin with. And I promised that this video would not be 40 minutes again, so I think we are going to call it quits because you probably spent a lot of time putting all of this in the calculator. You have to now try the homework, and when you try your homework, remember that your amount borrowed is equal to total cost minus the down payment, and your monthly payments are equal to 12 times a year times however many years that you have this loan for. Anyway, I hope you enjoy your weekend. Bye.